want to illustrate the improvement of cyclability using this figure. As is seen in this figure, zinc is comfortable at 8S site due to the covalent bond, but zinc is uncomfortable at 16C site. Therefore, as mentioned before, the zinc stabilizes the non-spinel structure. So, when magnesium ion is inserted into 16C site, even though zinc moves to 16C site, it is easy to return back to the original 8S site when magnesium is extracted. In this way, the reversibility in the structural change would be significantly enhanced. Okay, so here we show our new material recently developed, that is zinc-based spinel oxide, which can show a very excellent cyclability. At present, I'm sorry that I cannot tell the sample name, but because the paper is now under consideration. So, however, it is clearly indicated that zinc-based spinel oxide is one of the high potential cathode material candidates of the magnesium rechargeable batteries. Okay, let me summarize. So, so we have now been establishing divalent cation electrochemistry towards future battery systems of great safety, greatly safety, cheap, abundant, and high energy density. So spinel oxides are one of the candidates for the cathode materials, which transform to rock-salt structure, spinel to rock-salt transition, accompanied by the magnesium insertion at a moderate temperature. The energy density of the present MRV is much higher than that of the conventional magnesium battery and comparable to that of lithium battery, ion batteries. The most important issue is to be overcome in future is to enhance the cyclability, and maybe operation temperature must be reduced to the room temperature. Okay, so, thank you for your kind attention.
Yeah, thank you very much
for your presentation. We have a lot of time for questions, and I see that a lot of questions have already accumulated. Some of them might still be directed to Brian Ingram. I'm sure Max has a full overview and will moderate the question section successfully. If you are on the panel and you have a question, it is clear you cannot post questions in the question section. So if you're on the panel, it would also be okay if you unmute yourself and ask your question directly. I think that would be okay. All right, Max?
Yeah, definitely. I think this is the easiest. If you're a panelist and have a question, just unmute yourself, show up, and then we can have this question. So I see that there have been lots of questions coming in for Brian's talk. Here is one for Tetsu from Gregorio Ortiz. Nice work, Tetsu. Why the electrochemical performance is done at 150 degrees centigrade? What about the results at room temperature? Electrolytes should suffer at 150 degrees, right?
Yes, yes. So it's a very difficult to, so yes, the purpose, the next future object is reducing the temperature. So using, yes, so usually, so the electrochemical window of the electrolyte is a problem. So at a high temperature operation, yes.
Okay.
Okay.
Do you want to add something or?
No, so please.
The question was also, is your electrolyte stable at 150 degrees centigrade?
Yeah, yes. So there are a few candidates for such an excellent electrolyte, but now, so we are using the cesium-based TFSA ionic liquid, but so this is practically not used. So we cannot use this electrolyte practically. However, so Yes, this is a very problem. If you have a very nice electrolyte, please teach me. So,
okay. Yeah, one question from my side. I mean, the zinc iron oxide seems to be very exciting systems because this has very low barriers for migration. Did you synthesize it via the classical ceramic route, or did you use a special process? Was that necessary, or is everything standard in that case?
Yes. So it's a very standard method can be applied to produce the zinc Fe2O4. So yes, so our technique is only a co-precipitation method. Not special method. Therefore, maybe everyone can fabricate the powders.
Yeah. I saw in one of your slides, I think it was 23.
23.
23.
Okay.
That or maybe the one. No, it was another one. I was wrong. But the theoretical voltage that you calculated for this system was lower.
Yes. That's right. So in the case of zinc-based spinel material, so zinc is favors locating at the 8S site. Therefore, if magnesium ion is inserted into the matrix, so the spinel structure is very, very unstabilized. Therefore, so voltage is expected to be lower than the calculation. Yes.
Yeah. Okay. Because normally this is the other way around, right? You find voltages that are lower than those which were calculated.
Yes.
So I wonder whether there are more questions.
Okay.
I don't see any for the moment. Am I wrong? No.
Yeah, I also don't see any other questions. Is there a question from the panel? You could just use your microphone, mute yourself, and ask a question. Actually, that's not the case. I guess we'll save a little bit of time, and we'll already continue with the next presentation,